Okay, so next we move to the second part of this lesson, measures of central tendency. Okay, so over here we learn about, okay, look at this. A measure of location is a single value which describes a position in a data set. So a measure of location is a single value which describes the position where it is located. If the single value describes the center of the data, it is called a measure of central tendency. You should already know how to work out the mean, median, and mode of a set of ungrouped data and from ungrouped frequency tables. Okay, anyway, so we will revise this. You may have already heard of mean, median, mode through your O-level exams, but we will quickly go through that, how to find the mean, median, mode again for group data and for ungrouped data. Okay. So reminding you again, so what is this? The mode or model class is the value or class that occurs most often. Okay, so mode is the value, or in the case of a group table, the model class. It is the class that occurs most often. And what is the median? The median is the value when data values are put in order. Median is the middle value, exactly the value in the middle. Okay, and the other one is the mean. So we are talking about the three measures of location that we mainly use: mode, median, mean. So mean can be calculated using the formula x bar equals sigma x over n. This is for single x values. If there is no frequency, we use mean equals sigma x over n. You know what is sigma x? Have you seen this? Sigma x means what? If you have your x values and you add all the x values and divide by the number of data points, right? So if you have 10x values, you add all those 10x values, like the individual x values, and divide by 10, if n is 10. Okay, so x bar, so I think have you, so this, the notation x bar, when you see the letter x and on top this line on top, it means x bar, and immediately in your mind, it should be read as x bar means the mean of x, the average x value. Okay. And also there's one more theory they have given here, combining means. I think for these, it's better that we go with examples. Anyway, they say if set A of size n1 has mean x bar 1 and set B of size n2 has mean x bar 2, then the mean of the combined set of A and B is n1 x bar 1 plus n2 x bar 2 over n1 plus n2. Okay, for this, I think it's better we go with a just a small example. Okay, so for example, let's say you have set A, and in set A, let's say the mean of x bar, set A is, let's say it's 10, and let's say n is, there are 7 members in set A, and let's say there is set B, and mean of set B, let's say it's 15, and let's say set B has 10 members. So what do they ask you to do here? It's like there are two classes. So the mean of the first class is 10 with 7 members. Mean of the second class is 15 with 10 members. What do they want you to do here? Over here, what they want you to do is they want you to combine these two classes together. So end of the day, 10 plus 7, there are 17 members altogether. 17 members together. What is the combined mean of both of them together? That's what they want you to do here. So what according to this formula, what do you have to do? I think this formula makes sense to you. Should make sense, because if you realize mean, what is mean? Sigma x over n, right? So I think you might have done some similar to this in your O levels, where they give you the mean. So the mean is given to you as 10, right? So this 10 equals sigma x over the n value is 7. Okay. And then what do you do here? When you multiply the 10 with 7, you get 70, which means this is the total of the x values in the first group. Now there are 7 members here. Each member has an individual x value. Okay. So the total value of all these members, the x values are 70. Okay. And x bar 2, the mean is sigma x over n. So here the mean value is 15. Total x value is unknown here. N value is 10. Right. So what do I get here? 150 is sigma x2, which means the individual x values of the 15 members. If you add up the individual values of these 10 members, right? There are 10 members. Each member might have a different value. So the first member might have x value of 5. The other member might have x value of 7. I'm just saying. Altogether, when you add all the 10 members, so there are 10 x values. When you add it up, it's 150. So then how do you get the total mean? The combined mean. Combined mean is, as you can see here, this n1, x1, x bar 1. Can you see this is actually n1, x bar 1. When you multiply these two, you have actually got 70 as the n1, x bar 1. And here 150 is actually the n2 with x bar 2. Because this is the x bar 1 and this is the x bar 2. This is n1 and this is the n2 value. Isn't it? Can you guys see? So here 70 is the n1 x bar 1 and 150 is the n2 x bar 2. Are you with me? N1 x bar 1 plus N2 x bar 2 over N1 plus N2. So N1 x bar 1 value is 70. N2 x bar 2 is 150. Divide by N1 plus N2 is 10 plus 7, 17. And you can get the answer. So how much is it? 200, which is the 3SF. The combined mean of the two classes, 12.9, 12.94. So 3SF, 12.9. Okay, so this is how you use combined mean. So I think you might have done this slightly some kind of in this manner, questions in this manner in your O-level exam as well, right? Okay, so this is how the combined means are used, where you combine the means of two different classes and combine them into a single class. Recording in progress. Okay, so then we have again a similar equation for the mean. Now we saw in the previous question, the mean was given as sigma x over n, isn't it? That is when you have single x values. But over here, I think this is also an equation which you might have seen previously in O levels. So x by sigma fx over sigma f. This is what? This is when it is when there is a group frequency table. When there's a group frequency table, we go for x bar equals sigma xf or sigma fx over sigma f. So this is also, this equation is supposed to be used when you have a frequency table only. Okay. Okay, so now let's move to exercise 2B. Okay, question number 1. Priyanka collected wild mushrooms every day for a week. When she got home each day, she weighed them to the nearest 100 grams. The weights are shown below. So you can see the weights are given here, 500, 700. You can see it's given in a random order, right? So each day she collects wild mushrooms and then she weighs them to the nearest 100 and you can see the results given here. Write down the mode for these data and then part B, calculate the median, mean and the median. So you need to calculate the mode, mean and median. So when you get data, ungrouped data like this, what's the first thing that you need to do here before you go for the mode or for the especially before you do the median? You must arrange the data in ascending order. Okay, otherwise you cannot see the median. Okay, so first thing is to arrange data in ascending order. Okay, so let's do that. Let's arrange the data in ascending order. So it's gonna be smallest value here is 300. Next, 400, 500. There are 3 700s. 700, 700, 700. And then there are 3 700 and there's a 900. Okay, so you can see the same data set I have rearranged. You must rearrange. This is the first thing that you need to do. Okay. Okay, and then they ask you part A, write down the mode for these data. So part A, what is the mode for this data set? The most occurring value is 700. So it's in grams, 700 grams, it's the weight. And the most occurring data value 700 grams is the mode. Then they ask you calculate the mean for this data. In this case, to calculate the mean x bar, are you taking the sigma x over n rule or is it sigma fx over n? Do we have a frequency table here? No. So you will use x bar equals sigma x over n. So your individual x values are given here. Can you see? So you add each and every one of these individual x values and you get sigma x. So you add 300, 400, 500 and 700 along with the 900. And divide by how many data points? 1, 2, 3, 4, 5, 6, 7. There are 7 data points. So add everything and divide by 7 and you will get the mean. So we get here the addition of these values on top, it gives you 4,200, right? 4,200 divided by 7, which gives you 600 grams for the mean. Okay, so your mean x bar is 600 grams. Part C, they want you to find the median. Okay, so how do we calculate the median? Basically, this is a really small data set. You don't need to go for any complicated rules here. Simply the value that is in the middle. Simply the value that's in the middle. So how many values are there in the middle? So if you go from the corners, like you can, so you can see there are how many values in the middle? Only one value. So you can see this is the value in the middle. This 700 is exactly in the middle, right? So therefore median is 700 grams. Okay, median is 700 grams. That's the middle value. Okay. Now let's go for the next part. Okay, in part D, they say on the next day, Priyanka collected 650 grams of wild mushrooms. Okay. Write down the effect this will have on the mean, mode, and the median. Basically, they want you to find the effect that this effect in the sense they want you to describe whether the now you currently have you found some values for the mode, mean, and median, right? So now she has collected another set of data, and when you include that into this particular data set, they want you to describe the effect. Effect in the sense whether not the new value. They are not asking you to calculate the new value. Effect in the sense whether the current mean will increase or decrease or stay the same, whether the median will increase, decrease or stay the same, and whether the mode will increase, decrease or stay the same. That's what they mean by effect. Okay, they don't expect you to calculate here, not calculate. And they also say here in hint, try to answer part D without recalculating the averages. So in the exam, sometimes they clearly tell you, they give you this extra data point and they clearly tell you without calculating the new, without doing any calculation, comment on the effect that this data point will have on the mean, mode, and the median. Okay, so now you need to think. What happens when you add the value 650 grams to this particular data set? Okay, so she collects 650 grams. Now the question says when she gets home each day, she weighs them to the nearest 100 grams. So in that case, if you are if you add it to this particular data set, okay, we can say that to the nearest 100, 650 grams should be 700, right? So you can take it as 700, which means the nearest addition to this data set is another 700. Okay, so you're adding another 700 to this data set, which means it comes over here, right? Okay, so when you input the new 700, so you're inputting a new value called 700 into this data point, into this data set. So you can see it comes over here. Now, what you need to see is whether this 700, how it affects the mode, mean, and the median. Okay, so mode, clearly you can see currently our mode is 700. So when you include another value of 700, does it make any effect on our mode currently? No, it will still be 700. You will have 700 repeated 4 times. So mode will, you can give the comment, mode will remain the same. Mode will remain the same, or mode will be unchanged. And then let's talk about the mean. So currently your mean is 600. So currently our average weight is 600. You add a weight now that is more than the current mean. So what does that do? When you add a value that is more than your current mean, now 700, the value 700 is more than 600, which means what? Your mean will increase. Remember, if you add a new data point which is higher than your current mean, your mean will increase. If you add, say, let's say she add the new value that we adding here is 500. If the new value you adding is 500, what happens? The new value you add is lower than the current mean, which means the overall mean will decrease. Okay. But if let's say that the new value is 600, let's say the new value that you're adding here is 600. Your current mean is 600. The new value you're adding is also 600. In that case, mean will stay the same. So these are some really important things. Okay, the new data point which you are adding, if it is more higher than the mean, the overall mean of the new data set will increase. If the new data point that you're adding is lower than the previous mean, the overall mean of the new data set will decrease. If the new value we are adding is equal to the previous mean value, then overall the new mean value will remain the same. Okay. So you are adding 700, which is more than the previous mean. Therefore, mean will increase. You can say here mean will increase. Okay. Mean will increase since 700 grams is more than 600 because it's higher than the previous mean. What about the median? What about the median when you add another 700 over here? I think you can see when you add another 700, let's say I put the 700 anywhere over here. I think you can see now you get two values in the middle, isn't it? You can put the 700 anywhere because all of them are the same. So you can see that you will now get two values in the middle, which are both 700s. Both are 700s. Okay. So you can say your median will remain the same.